Hi, my name is Torie Roseborough, and today I'm from the Lunar Reconnaissance Orbiter Camera at Arizona State University. And today I will be talking about revisiting Apollo station activity times and their implications for Artemis III. So with the return to the lunar surface with Artemis III, it will require a number of mission planning decisions, including how best to allocate time for geology station tasks. And in order to inform these decisions, we can look back to the Apollo missions as a bit of a reference point to see how they did this. And in our study, we recorded and analyzed the time durations for 4 categories of tasks at all the geology stops of the landed Apollo missions. So we had 4 main categories. Our first was stop characterization, which included things like scouting for sample locations, site photography. We had core samples. We had standard samples, which included things like rock, soil, and rake samples. And for this category, we actually recorded the total sampling time at the station, as well as the time to take each sample. And our final category, which was stop cleanup, and that included things like stowing equipment and preparing to leave the site. So just a note about our terminology. In order to avoid confusion with the officially defined Apollo stations, we use the term stop. And we define a stop as any location where the astronauts spent at least 10 minutes on geologic site study. Where geologic site study was not the main focus, like at the LSEP or preparing and closing out the EVA at the lunar module, we only recorded the time per sample. And so this means that for Apollo 11, as well as EVA-1 of Apollos 12 and 14, which were mostly devoted to deploying equipment, those didn't have any stops, and we only recorded the time per sample. And just to talk a bit about the stops by mission type, so for Apollo 11, it didn't have any stops. Apollos 12 and 14, the stops were generally more consolidated than the officially defined stations. And for Apollos 15 through 17, the stops mapped onto the official stations. So in order to determine task times, we consulted our spatiotemporal mapping dataset, as well as the Apollo Lunar Surface Journal. And just a note, LROC's spatiotemporal maps provide the exact timings and locations of the Apollo astronauts' movements and activities on the surface. So they were a good record for finding the start and stop times for each of the tasks. Then for each astronaut, we recorded the start and end times for the entire geology stop, the entire duration of the stop, and for each task except stop characterization. And for stop characterization, we just assumed that any time not spent on the other tasks was spent characterizing the stop. So in order to calculate that, we summed the rest of the tasks and then subtracted that from the total stop time. So moving on to our results, because the station durations were not consistent over all of the missions, and because these generally scaled with the stop time, we actually look at these as percentages of the stop. So here are the percentages for each of the tasks for Apollos 12 through 14 as percentages of the total stop time. And you'll notice that these add up to over 100%. That's because they didn't do every single task at every station. So we can actually consider these as percentages of the tasks where they were done at a stop. So we notice a couple of things. First, we notice that there's some variation in core sampling time, which we think is due to not distinguishing between single, double, and triple cores. And it was a bit outside the scope of our analysis. Oops. The second thing that we notice is that stop cleanup is overall higher for Apollos 15 through 17. Those were the missions with a rover, and that rover could carry more equipment with them. And so that higher time devoted to stop cleanup is because they had to load everything back on the rover. And also, they had to board the rover, that sort of thing. So we also note that Apollo 14, which is going to have a handcart and no rover, is the most analogous mission to Artemis III. So that stop cleanup time is most appropriate and analogous for Artemis III. So taking a look at these overall average for amongst all the missions, we get a stop characterization percentage of 44.5%. Core samples were about 17.0%. Total standard sampling time of 37.1%, and a stop cleanup time of 11.9%. And just to take a look at our time per standard sample data set, these are our values for all 6 landed Apollo missions. And you can see that there's some variation amongst the data set, but those are all within a standard deviation because there's a lot of variation amongst the times. And they are all between 1 minute and 30 seconds to 3 minutes. We also note that we don't see it getting more efficient over time, which you might expect if it started out inefficient in terms of sampling rate. So we see that there's a lot of consistency. And then if we take all of the times and we average them out, then we have an average time per standard sample of 2 minutes and 6 seconds. So what can we learn from this data for Artemis III? First of all, we propose a task breakdown of stop characterization of about 40% of the time, core samples of about 15% of the time, total standard sampling time about 40%, and stop cleanup about 5%. And if we assume a 30-minute station length, which is actually the average stop duration on Apollo 14, that breaks down to about 12 minutes for stop characterization, 4 minutes and 30 seconds for core samples, 12 minutes for total standard sampling time, and 1 minute and 30 seconds for stop cleanup. And we also suggest that about 2 minutes should be allocated as a time per standard sample. We also note that time per sample was relatively consistent across the Apollo missions, which suggests a standard saturation point when it comes to sampling rate. And we also note that tasks scale with station duration. And so if you're looking at it from a pure standpoint of just trying to get the most samples collected, then you could increase station length, and that would maximize the number of samples collected.